You are welcome to Maths Hub S. Today we are going to look at a question in the just past 2025 Wassce examination in core maths. Actually, we're looking at all the questions, but today we are just looking at question number 1. Not just the question 1, but all the questions on the core maths paper this year was much of word problems. So what that means is that you have to read well and understand the question before you can even start to solve. Because for word problems, if you don't understand the question, it simply means that you can't solve the question. So you have to read, understand, write down your information, and then you try to connect the dots. After that, you proceed to solve the question. So if you look at the question number 1, it was, and I think this part of the question, this Wassce question was for Ghana. So Ghanaians will be much more familiar with this question maybe as compared to other African countries. So the question number 1 was, a bus travels between two stations, Paga and Kappa, covering the first half of the distance at an average speed of 60 kilometers per hour and the second half at 90 kilometers per hour. The total distance between the two stations is 300 kilometers. So the question number 1, first part of the question, that is A, was calculate for the entire journey the average speed of the bus. And then the B was, if the speed of the bus in the first half of the journey is reduced to 50 kilometers per hour, determine its effect on the overall time. First of all, we are talking about two stations. The two stations here, we can simply think about them like 2 points, maybe point A and point B. So let's say the bus starts from a certain point A and then gets to a certain point B. The distance between the 2 points, that is from A to B, is 300 kilometers. Now, the question goes on to say that the distance has been divided into two halves. So we have first half and then second half. So once the question is saying that first half, then it means that we have to divide the distance into two so that we get 150 kilometers for the first half and then 150 kilometers for the second half. So the total in this case is 300 kilometers. So first half means that 300 kilometers divided by 2, and that will be 150 kilometers for the first half. Then the rest of the journey, which is the other 150 kilometers, is for the second half. Right. So the first half of the journey, the car was traveling at an average speed of 60 kilometers per hour. Then the second half, it increases the speed from 60 kilometers to 90 kilometers. This can be linked to a real life situations, right? If you're speeding at a certain speed and then along the way you realize that maybe you are getting late or something of that sort, you can simply increase your speed. So initially the bus was moving at 60 kilometers per hour. But then after first half of the journey, which was 150 kilometers, it now decided to increase the speed from 60 to 90 kilometers per hour. So those are some of the things we need to get right before we even start to solve the question. Now the question is that A is that calculate for the entire journey the average speed of the bus. So we need to know, how do we calculate average speed, or how do we calculate speed? Speed is basically equal to distance over time. So let's go into that. So we are calculating the average speed of the bus throughout the entire journey. So average speed is giving us distance divided by time. Distance over time. So to get the average speed of the bus throughout the entire journey, then we need to divide the total distance of the journey by the total time used to cover the entire distance. But in this case, we know that the total distance of the journey is 300 kilometers. So we have total distance equal to 300 kilometers. Then total time. So for now, we don't know the total time. And since we don't know the total time, it means that we need to find the total time first before we can now solve for the average speed of the bus. How do we get the total time? We know that the total time, we know that the entire journey has been divided into two: first half of the journey and the second half of the journey. The first half of the journey, the bus was moving at 60 kilometers per hour. So we can read the question again to get what we are trying to say here clear. So we have a bus travels between two stations, Baga and Kappa, covering the first half of the journey at an average speed of 60 kilometers per hour. So the first half of the journey, the bus was moving at an average speed of 60 kilometers per hour. And note that this speed was used to cover a distance of 150 kilometers. So to get the total time involved, then it means that we have to get the time used to cover the first part of the journey plus the time used to cover the second part of the journey. That will be T1 plus T2. That will give us the total time involved. So we have that. We need to calculate for the time involved in the first half, and then we also need to calculate for the time involved in the second half. If we get those two times, then we can add them together to get the total time involved in covering the entire journey. So we say for the first half of the journey, for the first half of the journey. So once you write this, then you write down the information that you know about the first half of the journey. So we know that the average speed is equal to 60 kilometers per hour. That is for the first half. Then distance is equal to 150 kilometers. Once we know average speed and we also know distance, then we can solve for the time involved, right? By using the formula average speed is equal to distance over time. Distance over time. So here we proceed. So now we can do the substitutions that we know. Average speed is 60. So we can say 60 is equal to distance is 150, and then time is t. So we make t the subject from there, and that means that we cross multiply, we are getting 60t to be equal to 150. We are looking for t, so we divide through by 60, and then if we do that, our answer is 2.5. So what it means is that when the car was moving at 60 kilometers per hour, it used 2.5 hours to cover 150 kilometers, which was first part of the journey. So now we need the time that it will use to cover the second part of the journey, which is 150. But then it has increased its speed from 60 to 90 kilometers per hour. Then once the speed has increased, you're expecting that the time will decrease. So what that means is that our second time, our T2 is not going to be up to 2.5 because the speed has increased. Once the speed has increased and the distance remain the same, 150 for first half, 150 for second half, it means that your time will decrease. So if you solve for T2 or time for the second part of the journey and it is bigger than 2.5, then that means that probably you did a mistake somewhere and you need to go back and verify or go through your calculations again and check, because your time will definitely be less than 2.5, right? So we are now solving for second part of the journey. So we write for second half, we know that average speed for second half is equal to 90 kilometers per hour. And then we know that distance remains the same. Our distance remains the same. So distance equal to so now we try to solve for T2 or time used to cover the second part of the journey. Average speed using the same formula. So we are saying average speed is equal to distance over time. Now this implies average speed, which is 90, equal to distance, which is 150 over time. So which we can shorten it to be T. So from here, we make T the subject. Thus we cross multiply, and that means 90 will multiply by T to get 90T equal to 150. So that implies we are looking for T, right? So we divide through by 90. Divide through by 90. 90 divides 90 and we get 1 there. Now 1, we getting 1.67. So as I was saying, you can see that the first time, which was 2.2 hours, is definitely greater than this one, which is 1.67 hours. Since speed increases, you expect time to decreases. So even without going over, this gives us some confidence that what we are doing is correct, since the time for the second half of the journey is less than the time for the first half of the journey. So we now proceed to find total time. That will be equal to 2.5 for the first half of the journey, and then the second half 1.67, getting 4 point, and this is equal to 4.17. So we can now proceed to find the average speed for the entire journey. Average speed, total distance, over total time. and that means average speed is now equal to total distance as given in the question is 300, and then total time is 4.17 hours, and that means 300 is divided by 1 is divided by 4.1417, and we're getting 71.9, which we can approximate to 72. Know this is speed, so that'll be kilometers per hour. And that's it for the first half of the question, which is on the A. So here clearly you see that the average time is going to be in between the 60 kilometers per hour and that of the 90 kilometers per hour. It's going to be, the mean of that, or the average of that. So getting 72 kilometers per hour gives you confidence that you are not out of range and you will be correct, or you are correct. But if you solve and maybe your average time falls below 60 or is above 90, then that should tell you that your calculation is wrong. So we can move on to the B part of the question. So if we come to B, it's saying that if the speed of the bus in the first half of the journey is reduced to 50 kilometers per hour, determine its effect on the overall time. So here, initially the speed was 60 kilometers per hour. So the question is, if that speed was rather 50 or was reduced to 50 kilometers per hour in the first half of the journey, what would have been its effect on the overall time, right? So here, what we can say before we even start solving is that the time has reduced from 60 kilometers to 50 kilometers. It's telling you that once the speed has reduced from 60 kilometers per hour to 50 kilometers per hour, it's telling you that you are now going to use more time to cover 150 kilometers because your speed has reduced. If your speed reduces, it means that you are going to take a longer time to cover a distance. But if you increases your speed, you're going to take smaller time to cover that same distance, right? So here, if the speed has decreased from 60 to 50, it's expected that our time, which will be used to cover 150 kilometers, will also increase. Note that the first one, when we calculated using the 60, we had 2.5 hours. And now that the speed has decreased to 50, means that we are going to get a time which is more than 2.5 hours. So let's do the solving, or let's solve it. So all that we need here is to calculate the time for the first half of the journey using 50 kilometers per hour. And if we do that, then we can get everything right. You can say B, if average speed is equal to 50, then that means that we are going to get 50 to be equal to the distance, which is 150 over t. So here we can make t the subject, and that is 50t to be equal to 150. So we divide by 50. We divide by 50. And that means that T will be equal to 3. So the overall effect is that the time will increase from 2.5 to 3, and that will affect the general time. Therefore, we now have the new time being 3 plus 1.67, which is equal to 4.67. So that's it for the day, and we meet again in our next lesson. Thank you.